Hello everybody. You've got a brand spanking new note packet, and we're going to start off chapter 11 today. Thanks for joining me here with a video lesson since I am not available to be in class right now. What are we going to learn about this chapter? Well, as you can read from our learning target at the top of your note packet, I can compose and decompose figures to find perimeter and area. So what we're really focusing on here, this chapter, is going to be finding area. That's the big thing. Now, when it says compose and decompose, what does that mean? Well, to compose means that you're going to put something together. You're going to build things. So we're going to look at a lot of different area formulas for the shapes that you are already familiar with. What we need to do, though, is we need to be able to use those different shapes to find the area or perimeter of something that's a little bit different shape. That basically we can decompose some strange looking shape. We can break it down into parts that we can find the area of individually, so we can find the area of the entire thing, or perhaps perimeter. So today we're going to start with four formulas for area: square, rectangle, triangle, and parallelogram. You may be familiar with these already. We're going to try to understand why these area formulas are what they are, and then we're going to put them to use. Going back to the learning target, simply being able to plug things like base and height into a formula is not the level of thinking that we're after here. We're after being able to think at a higher level to possibly solve for these missing dimensions that we need to find the area. And then, like I said, breaking down objects into shapes that we can find the area of individually, so we can find the area of the greater one. So square, rectangle, triangle, and parallelogram. Looking at these shapes, it reminds me of a joke. Okay, and I know that there's been some requests for more jokes in my video. What do you call a squashed angle? Okay, if you said a rectangle, you'd be correct. Very good. All right, so I'm going to step away from our note packet here real quickly just to make sure that we understand the area of a square. Okay, so let me draw a square. Okay. So when we are looking at finding areas, what kind of units do we use? We use square units, simply because I can draw basically any shape I'd like, and we're talking about the region that this shape takes up in square units. Okay, so if I look right here, that is 1 square unit. If I look at this rectangle, if I want to know the area, I want to know how many square units, literally how many little squares does it take to make up this rectangle. So when we talk about an area of a square, it's pretty simple here. We're going to be multiplying the base times the height. Okay. Now, if the square is, let's say, something like this. Okay. This is 3 by 3. The area is 9. We can see all 9 square units that make up this square. So our area formula for this is pretty simple. We are going to take the side length and square it. That's why they called the second power squared. It's because really what you're doing is you're finding the area of the square with this as its side length. Okay. So in your notes here, okay, in addition to our vocab, which we can see up here, okay, I have given you a formula sheet. I'm already helping you try to be organized here with all the different formulas that you're going to be finding. In each of these boxes, we'll draw a diagram of the object that we are finding the area of, and then we'll write the formula. So our area of a square, okay. Now a square, all the side lengths are the same. If this is S, this is S, this is S, that is S, our area formula is simply S squared. Now let's go to a rectangle. I'm sure you guys are familiar with defining the area of the rectangle. Oops, that's not a rectangle. Well, it is a rectangle, but it's more specifically a square. That's not what I'm interested in. Here we go. Okay. All right, how do I find the area of a rectangle? Well, base times height. I take the base of the rectangle times its height. Now, sometimes you hear length times width. Same thing, just different words. I'm going to tend to use base and height here to understand why this is our area formula. Okay. Let me just draw a rectangle. Okay. This is 2. That's 5. We can see that the area here is 10 square units. Now, when I think about this, just remember that multiplication is just a faster way of adding things, of repeated addition. So we can simply take 2 times 5. That's how we can count those squares. Okay. Base times height. Okay. Now I'm going to jump to parallelogram here before we go back to triangle. Think if you know what the area formula for a parallelogram is. Okay. Anybody familiar with this? How do I find the area of a parallelogram? Well, it's pretty simple. You find the area the same way that you find the area of the rectangle. You take its base times its height. Now, here's its base. Where's its height? Okay. Well, it's important to remember that when we talk about height, we are talking about a distance between bases, or between a vertex and a base. And that height must always be perpendicular to the base. So I could draw in the height of my parallelogram right there. Okay. Or I could draw in the height of my parallelogram right there. I could even draw in the height of my parallelogram over here if I extend the base. Okay. So the height of our parallelogram is going to be the distance between the bases, okay, which must be perpendicular. Now, before I forget, okay, I believe that is one of our vocabs. There we go. Our height of a polygon. Okay. The height of a polygon, okay, is the length of the segment well, let's say this, the length of the perpendicular segment between the bases, or from a vertex to a base. Just draw a quick picture here. Okay. If it's a triangle, it's a parallelogram. Our height has got to be perpendicular. That's a bad drawing there. Okay, there we go. So, okay, why can we just take the area of the base, or the length of the base, times the height to find the area of a parallelogram? Why does this work? Okay. Well, one thing I could consider doing is taking my parallelogram, chopping off this triangle, and simply sliding it over here. Now, when I do that, all this is gone. Okay. And when I look at my big shape, I have a rectangle. Notice the height of this rectangle was the height of the parallelogram, wasn't it? Okay. The base, okay, now did I change the length of the base of the parallelogram? Well, look across the top here. Okay. In a parallelogram, we know opposite sides are congruent. So the base that was down here is the same as the base that was up here. Did I change the length of this? No, I didn't. This is still B. This is still B. In fact, I took what was on the left and slid it over to the right. The length didn't change. So the area of our parallelogram, it makes sense. It's the same as the area of a rectangle. It's the base times the height. Oh, and look at that. When I draw on the height with my right angle symbol, it kind of looks like an H. Area of a parallelogram, base times height. All right, now let's go to the triangle. I'm going to draw a triangle. I'm going to draw the height. It's going to go from the vertex. It's going to be perpendicular to the opposite base. Here's the base. There's the height. How do I find the area of a triangle? You guys are familiar with this. You've known how to do this for a long time. It's 1/2 the base times the height. But why is the area of a triangle 1/2 the base times the height? Well, a lot of students would tell me it's because it's half of a rectangle. Okay? 1/2 base times height means we're taking 1/2 the area of a rectangle. That's true if the triangle is a right triangle. Okay? If I draw a right triangle here, there's the base. If this is a right angle, my height is that side length. And if I double my triangle, I would have a rectangle. Okay? And the area of the triangle is half that of the rectangle. But what if it's not a right triangle? Okay. Here's my base. There's my height. Is this still half of a rectangle? No, it's not. What is it half of? It's half of a parallelogram with the same base and the same height. That's why our area formula works for triangles, 1/2 base times height, because every triangle, whether it's a right triangle or an oblique triangle, is always half the area of the parallelogram with the same base and the same height. Okay. So we're going to get into examples now. We'll start with some simpler ones. We'll work into some more where we're decomposing or composing areas like we talked about at the beginning. All right, going too far here. All right, find the area of this parallelogram. Let's do it like this. All right, find the area of a parallelogram. We know how to find the area of a parallelogram. It's the base times the height. So option 1, what could I use as the base of my parallelogram? Well, I could use 9 for the base of my parallelogram. Now, if 9 is my base, this length down here, we know the height has to go from the opposite base and be perpendicular to this base. Where do we see the height? Is 4.5 the height of the parallelogram if I'm using 9 as my base? No, the 4.5 does not form a right angle with the side length of a 9. Okay? The height is actually over here. Okay? See how it forms a right angle if I extend my base right there? Isn't the distance between these two bases 4? So one way I could find the area of this parallelogram is to take the length of the base 9 times the height, which is 4, gives me 36 square units. Now I put a second option in here because if I didn't want to use 9 as my base, I could choose to use 8 as my base instead. Now if 8 is my base, what's my height? Well, what is the distance between this side of the parallelogram and that side of the parallelogram? Well, we've got to measure it with a right angle with a perpendicular segment. Okay. This 4.5 is the perpendicular segment between the bases. So I could take 8 times 4.5 instead. And what's 8 times 4.5? Again, 36 square units. We get the same answer either way. Now, not every problem are you going to know, okay, the height from either way. So sometimes you have to decide what do you know. For example, if this wasn't here, I would have to use option 2 to find the area. If this wasn't here, I would have to use option 1 to find the area. All right, several more areas that we're going to find. All right, let's start with this. This is a triangle. Our area formula is 1/2 base times height. We're going to go 1/2. Now, what's my base? What's my height? I have to look for the height first. Where's my perpendicular segment that I know? This is my perpendicular segment right there. That's my height. So if I'm choosing 28 as my height, the base has to be the side that's perpendicular to it, okay, which is this right here. Now be careful. We have to take the entire length of the base. 45 and 21 is 66. So we're going to take 1/2 66 times the height, which is 28. I need to get my calculator out. I've got 924 square units. All right, let's head over to this, recognize our shape. Okay, we've got a parallelogram, base times height. Well, I've got this is 17, this is 10, that's 7. You guys should recognize that this perpendicular segment is the height, so 7's our height. What are we going to use for our base then? What is this segment perpendicular to? It's perpendicular to the 17. So this is going to be the base 17 times the height, which is 7. 119 square units. Good, let's keep cruising here. Okay. Well, I've got a rectangle in this one. Area of the base times, sorry, I don't know why I keep saying area of the base. I must be thinking about three-dimensional objects already. Length of the base times the height, okay, because it's a rectangle. Oh wait, or is it a parallelogram? Oh, that's right, rectangles are parallelograms. That's why the area formulas are the same. Okay, the base is 9, the height is 3. The area of this rectangle or parallelogram is 27 square units. All right, last one on this screen. Okay, we've got a square. Or is it a rectangle? Or is it a parallelogram? Doesn't matter. You're going to find the area all the same way. Our area formula, we said, is the side length squared. This is 9 squared, or 81 square units. Okay. Now, I know some people like to think of it this way. They go 9, this is 9. So they use the rectangle formula, or they use the parallelogram formula. Take 9 times 9 base times height. You get the same thing, 81 square units. All right, let's keep moving. Triangle, area of the bay, 1/2 base times height. This is 1/2. What's the length of our base? What's our height? Well, we know our height has to be perpendicular. Okay. This is a right triangle. So this can be my height, then that has to be my base. Or maybe this is my height and that's my base. Whatever way that you look at it, it's going to be fine. Okay? But we're missing one of them, aren't we? Okay? If I'm going to find the area of this triangle, I need to know this side length. The 13 is not the base nor the height, okay? But it is helpful, okay? Because the 13 along with this 12 is going to allow us to solve for this. Use the Pythagorean theorem, a squared plus b squared equals c squared, you can solve for this. I'm not going to do all that work because I see 12, 13. I remember a Pythagorean triple, 5, 12, 13. So we're going to take 1/2 5 times 12, which is 30 square units. Any questions so far? Awesome, you're doing great. Keep it up. All right, switching up question type here a little bit. The base of a triangle is 4 times its height. If the area is 50 square inches, what is its base and its height? Notice in this problem, I give you the area. We're working backwards. I want to know the base and the height. Now, we're working with the triangle here, and the base of the triangle is 4 times its height. Does not tell us what type of triangle it is. It could be a right triangle. It could be an oblique triangle. We don't know. Okay? But I'm just going to try to sketch a triangle where the height of the triangle is roughly, the base of the triangle is roughly 4 times its height. Okay? Here's my base. There's my height. Okay? Now, the base is 4 times the height. So if I call the height h, I can call the base 4h. So our area formula is 1/2 base times height. Let's substitute in. 50, what's that going in for? A, the area. The base, what are we going to put in there? 4h. The height, we'll leave that as h. You can see when I substitute the 50 for the a, the 4h in for the b, I have an equation with only one variable. Okay, that's an h, and we can solve this. Okay. 1/2 of 4 is 2. This is all multiplication. H times h is h squared. Okay, so here we go. 50 equals 2h squared. Divide each side by 2. 25 equals h squared. Take the square root, and the height is 5. So let's make sure we're thorough when we answer our question. What is the base and the height? Okay. Well, the height is 5 what? If the area is 50 square inches, the height is 5 inches. Okay. The base is 4 times the height. The base is 20 inches. Make sure that you guys are being careful with your units. I'm going to demand that you guys are labeling all of your answers with the appropriate units. The area was in square inches. The base and the height are inches, their lengths. All right, let's get to that composing and decomposing stuff here. Okay. A couple important theorems for us that will help us with that. First one, if two polygons are congruent, then they have the same area. Okay, that makes sense to us. We know what area looks like. If two objects are congruent, that means they're the same shape and the same size. Their areas must be the same. Postulate 26, our 26th postulate of the school year. Okay. Area addition postulate. We've had several addition postulates throughout the year. This one says the area of a region is the sum of the areas of the non-overlapping parts. If I want to find the area of an object that I don't have a formula for, kind of like this one down here, okay, I can find the area of that by adding together areas of non-overlapping parts. Okay. So let's look at this one, a robotic vacuum cleaner. Have you have one or you've seen one used before? Okay, it can clean 2 square meters of carpet in 8 minutes. How long does it take to clean a carpet covering a room with these dimensions? So the first thing that we need to figure out of this is what is the area of the room? Once we know the area of the room, we can figure out how long it's going to take. Okay. So what I want to do is I want to use this area addition postulate to split this region into non-overlapping parts that I can find the area of each. A few different ways that you can do that. Some students like to split it like this. Some students like to split it like that. Doesn't make a difference to me which one we're going to do. I'll go with the first one that I drew. Okay. Now I can find the area of each of these two shapes. Down here we have a square. Up here we have a rectangle. So my area is going to be the area, I like to use little subscripts here. It's going to be the area of the square plus the area of the rectangle. Alright, so the square, what are the dimensions of the square? 5 by 5, so that's 5 squared. Area of the rectangle, base 9, height. How long is this? Do we know that? We certainly do. Okay, well, if this is 5 over here, this is 5. The total length is 9. Using the segment addition postulate, we know that this would have to be 4. So we're taking 5 squared plus 9 times 4. That's 25 plus 36, or 61. What are our units here? Square meters. All right, now that wasn't the answer to the question. Okay, we're still problem solving here. How long does it take to clean the carpet? Okay, well, it can clean 2 square meters of carpet in 8 minutes. Okay, I'm going to do something that it's been a little while since we've done this in class. I'm going to use multiplying fractions here with my unit analysis to change my area into time. So the way that I'm going to do this is I'm going to take 61 square meters, I'm going to put it over 1 times. I can't clean, the robot can clean 2 square meters of carpet in 8 minutes. I want my square meters to cancel out. I want my answer to be a time, minutes. So I'm going to put my 8 minutes in the numerator and my 2 square meters in the denominator. When I do that, I see my square meters cancel out, and the only units that I have left are minutes. So I can take 61 times 8 divided by 1 times 2. 61 times 8 divided by 2. You may notice that this would simplify if we want to do this instead. The 2 and the 8 reduce to a 1 and a 4. All I have to do is take 61 times 4, 244 minutes. So, just over 4 hours. Very good. Alright, you're using a roller to smooth a lawn. You've ever done that before? Maybe you've laid sod, you've taken a roller, which is like a cylinder, you fill it with water, make it heavy, you can roll it over the lawn to smooth it out. You can roll about 125 square yards in 1 minute. How many minutes does it take to roll a lawn that is 120 feet long and 75 feet wide? Alright, well, let's sketch this. Okay. Now, when it gives the dimensions like this, 120 feet long and 75 feet wide, I think it's safe to assume that this lawn is in the shape of a rectangle. Where we've got 120 feet, we have 75 feet. All right, same thing here. We're looking for time, but we know we first need to find area. If this is a rectangle, we're going to take 120 times 75, 9,000 square what? Yards. Reminds me of a problem. So have you ever used a 3-foot ruler? Do you know where you can buy those 3-foot rulers? At a yard sale. Boom. All right. Full of jokes today. All right, so just like last problem, we're going to take this area and we want an answer in time, in minutes. So we're going to use that same process. I'm going to take my area. I'm going to put it over 1. I'm going to multiply it by another fraction. Just like last time, why did I Thinking about my joke too much, I goofed up my units. This is not yards. Huh, why do you think I got goofed up here? That's square feet. Huh. So then I'm going to multiply by what? Well, I want square feet to cancel. What do I know? I can roll about 125 square yards. That's probably why I got goofed up. We're talking feet, yards, and minutes. Can I multiply by 125 square yards down here and have our square feet cancel? No, I can't. What I first need to do is I need to change my square feet into square yards. Then I can cancel them out to find my time. So here's the question. I want square feet to cancel so I can have square yards. How many square feet are in a square yard? Is it 3? Let's think about this just a second. If I have a square yard, that means it's 1 yard by 1 yard. Okay. Well, how long is 1 yard? 1 yard is 3 feet. So it's 3 feet by 3 feet. So what's the area of 1 square yard? 9 square feet. So what I need to do here is I need to multiply by 1 square yard over 9 square feet. Now my square feet cancel. Now that I have my area in square yards, now I'm going to convert it to time. What do I know? I can roll 125 square yards in 1 minute. So I'm going to multiply by another fraction. This time my square yards need to cancel, and I need to have time left, 1 minute. In 1 minute I can roll 125 square yards. The square yards cancel, and here we go. I need to take 9,000 times 1 times 1 divided by 1 times 9 times 125. Okay, here we go. I'm going to take 9,000 divided by 9 times 125, and I get 8. My units, the only unit left, is 8 minutes. So it's going to take 8 minutes to roll a lawn that's 120 feet long and 75 feet wide. Now, I do have students ask me this sometimes. Could have I just changed the feet to yards to begin with? Yes. If you wanted to change 120 feet into yards and 75 feet into yards and then find the area, that's fine. You're going to get the same thing. I just found the area with the dimensions they gave me and then converted square feet to square yards. You could convert these to yards and then find your area in square yards first. That's just fine. Now, suppose the lawn is half as long and half as wide. Will it take half the time to roll? If this was 60 feet by 38.5 feet, would it take 4 minutes instead of 8 minutes? Okay. Is it going to take half as long because the length is in half and the width is in half? Well, picture this. If I split the length in half, that's now 60. And I split the width in half, that wasn't great, let's just slide it down a hair, in half like that. I'm really only having this much of the lawn left. So is it going to take half the time? No, it's going to take 1/4 the time. I don't even need to crunch the numbers here. Look at that visually. If I take half the length and half the width, I'm going to have 1/4 of the area left. It's only going to take 2 minutes to do that long. All right, what I would like you to do next, okay, is I have just a few more problems. Okay. I would like you to pause the video. I would like you to try these on your own. Once you've tried these on your own, go ahead and play the video. Okay, and I will put up my work so you can check it. So go ahead and pause the video now. All right, here's my work. Go ahead and take a look. First one I plugged in. I solved for the base, got the base to be 7 feet. Again, make sure that you're giving all your units. Example 7. Okay. Solving for the height in this one, I got 18 feet. Solving for the base in this one, I got 24 inches. And then our last one, finding the area of this home plate looking object. I split it into a rectangle and a triangle, used the area addition postulate, got 162 square units. All right, thanks for tuning in. Now it's time to practice totally on your own. What did the acorn say when he grew up? Gee, I'm a tree. Thank you. See you later.